Welcome to ThinkTech on OC16, Hawaii's weekly newscast on things that matter to tech and to Hawaii. I'm your host, Duke Oishi.
And I'm your co-host, Maria Kashem.
In this show, we'll visit the UH research facility at Snug Harbor for the launch of a high-tech harbor and port security vehicle.
This new technology is impressive and promising for homeland security and a notable success for research at UH Manoa.
As you will see, this is a very clever and powerful vehicle capable of protecting any given harbor from all kinds of risks, damages, and dangers. It is a myriad of good ideas rolled into a compact, high-tech package that will be useful anywhere.
The vehicle, technically an unmanned port security vessel, a UPSV, is a robotic platform designed for harbor and port security, including infrastructure inspection and incident response, and harbor surveillance.
It was not lost on anyone that the vehicle was designed, developed, and built by UH researchers, students, and contractors right here in Hawaii. It is a feather in the cap for research at UH.
We got to see the vehicle that day and talk with Brian Bingham. He is the principal investigator of the group that built it. If a tsunami hit Hawaii, Bingham said, the vehicle could be delivered very quickly via helicopter and within a few hours could remap the harbor for debris and obstructions.
We work very closely with SOES, the School of Oceanography, Earth Science and Technology. So my area of expertise is marine robotics. And we worked with a Center for Excellence in Homeland Security at Manoa, which put us in touch with the Coast Guard. And we're trying to solve a need for the Coast Guard of being able to quickly survey ports and harbors in response to events, natural disasters, tsunamis, hurricanes, terrorist events. So we have sonar sensors, so multi-beam, side-scan sonar, chemical sensors, dissolved oxygen, salinity, temperature, so to measure, looking for pollution. So it can make maps of the bottom. It has an infrared camera and regular video camera to be able to do inspections like underneath the piers, over in the pilings over there. So you know, that's what we wanted. That's what we felt like the Coast Guard wanted from our conversations. You know, that's what we feel like we need, and we've pretty much integrated everything. So side scan sonar gives you a very nice two-dimensional image. So you can look for, you know, if the body recoveries is one thing that they unfortunately have to do a lot. Being able to map these piers and pilings you're seeing out here, so look for anything that shouldn't be there. After an event, so one of the main emphasis for DHS and the Coast Guard for this kind of technology is what they call port resilience. So after an event happens, after there's a tsunami, after there's a hurricane, Hurricane Katrina, it took them weeks and weeks to be able to bring goods and services back into the port. So this allows them to more quickly certify the pier to bring a container ship in. In the Port of Seattle, they closed down the cruise terminal for like 2-3 months because they found unexploded ordnance, and they had to do diver surveys. It took months and months. We can do it in days. Working from the bow backwards, the first thing you see is a white dome. That's the infrared camera. It's an off-the-shelf infrared camera, which then goes to a wireless transmitter that comes back to shore. And then it's got an aluminum box, which has the embedded computer, GPS, inertial measurement unit, radio link. So the radio link's good to about 5 miles, so we can monitor its progress and control it from 5 miles away. And then antennas, so GPS antenna, that 900 megahertz radio antenna, and a 2.4 gigahertz antenna for the wireless video transmission. And then below the waterline, what you can't see is got a multi-beam sonar, dissolved oxygen sensor, salinity and temperature sensor, and a side scan sonar. So two different sonar devices. And then inside the hulls is where the main batteries are. So lithium-ion batteries, air shippable, that drive the thrusters.
This vehicle was built kind of in response to Hurricane Katrina, where Coast Guard found it very difficult to enter a port after there's a lot of debris in the water. And to be able to go in and identify what's obstructing a port and how to get the port back open really aids in resiliency. It shortens the time to recovery, and we think this is a better, faster, cheaper way to do it. The command and control is actually operated on an RF frequency, 900 megahertz, so they can be up to 5 to 30 miles away. 30 miles, of course, is dry air in the middle of the desert with nothing between you and the receiver. But with a set-off of 5 inches, what makes this vehicle very responsive is that you can put it in danger. You can put it in places where you don't know what's going to happen. If there's a suspicious package or if you're approaching an unknown vessel, the operator doesn't have to be on the vessel, so it's a kind of standoff thing. There's also an autonomous control where you can pre-program the vehicle to, say, map the seafloor in a particular pattern. And it will do that just by itself with no hands-on control. A lot of people would be good customers for it. We've talked to police departments, for example, in Boston, where every 5 to 6 days they have to inspect a liquid natural gas facility before the ship arrives. They put 8 guys in the water every 5 or 6 days to inspect this thing. And they're looking at this vehicle saying, wow, with this we could put 3 guys in the water and do the inspection remotely.
The vehicle is rapidly deployable and can map the seafloor, photograph infrastructure, detect chemical leaks and spills, and relay real-time video. With that technology, it can provide critical support to first responders and maritime security personnel around the world.
The development of the vehicle has led to an agreement between UH and Battelle, a global innovation company headquartered in Columbus, Ohio, which serves the national security, energy, and environmental industries and builds manned and unmanned vehicles, among other things. See battelle.org.
I'm here because of our partnership with the University of Hawaii, and in particular with the Unmanned Port Security Vessel. We're looking at this as an opportunity to grow and develop a relationship with the University of Hawaii beyond just the Unmanned Port Security Vessel. But their interest currently is in taking and transitioning this technology from a professor-student assembled, operated device to something that can be operated by either the Coast Guard, Department of Homeland Security, firemen, policemen, port security people.
So you might manufacture this?
Yes. That's actually something new to Battelle. You know, Battelle has always worked with organizations to help them transition things to manufacturing, but we do the documentation and work with them to take and create something that's manufacturable. Everything from things like sonic toothbrushes to plastic coating on golf balls to the sandwich coins, the penny, dime, nickel, quarter. And we weren't the manufacturers, but about 10 years ago we started taking and doing limited scale manufacturing. So high complexity, low to medium volume. And so when we look at things like this kind of fits into that. It's not going to be something that's sold into hundreds of thousands. It's going to be sold in the tens to hundreds. And so I'd love to be sold in hundreds of thousands or tens of thousands, but most likely it's not going to be sold at those really high numbers. And it's a fairly complex device, but it's also designed to be economical. And so it fits really well in our manufacturing technology capability. And it being an agnostic platform, as Kevin was talking about, it allows you to take and put a variety of different sensors on it, so you can meet a lot of different mission requirements. So if you're trying to do port security, you can have the forward-looking infrared camera and a side scan sonar, and you can take and do just point-to-point surveys through port area and just do security runs. Or if you're looking for a drowning victim, you can take and do the side scan sonar, and you can take and do a grid pattern, take and look for body recoveries. And so there's a lot of different things which you can do with this system, whether it's environmental monitoring. You can take and put environmental sensors on it, dissolved oxygen, pH, salinity, CO2, dissolved inert carbon, and you can drive in through an area and do a profile, and you can do that over and over again, and you don't have to put out a crew of people to do that. When you as a person who's designed it or building it versus someone who's building it who isn't familiar with design, you want to take and simplify that. You want to make it so that they can't put things together incorrectly. There's a lot of places where right now they use the threaded fasteners on this, and when someone's doing a drowning body or a hurricane's gone through and they're looking for cargo that's on the bottom of the Bay Area, people are going to be stressed. The weather conditions aren't going to necessarily be good, so you're not going to have the luxury of a nice lab environment to put things together. And so you want to have things that are really, I'll call them idiot resistance, because you can't make anything idiot proof. And so you'll go from threaded fasteners to cam lock devices and things of that nature. You'll make sure the fasteners are fasteners that you can't interchange two fasteners that might cause something to catch on fire. When someone gets this, it's going to be in crates, and there's going to be, the pontoons are going to be separate from the platform, and you're going to have to assemble those, and you're going to have to connect the sensors that you're wanting to use for your mission. And so by designing those so that you don't really need manual, you can look at it and go, there's only one spot this connector will plug into, so I'm going to assume it goes into that one spot. And so doing those kinds of things.
So do you have any idea what the price point might be for the basic unit?
Have no clue yet. Right now, they're on their second evolution of this design. There will probably be one more evolution on this design before it makes a transition. And then what will happen is
KGMB does that to us all the time.
Okay, so they're on their second evolution of this design. The first evolution of the design was a little bit smaller, a lot more complex, a little bit more difficult to put together. They evolved a lot in this design. It's a lot closer to something that can be transitioned to manufacturing and used by other people. But it's going to need one more turn on that crank to take care of some of those small things that just make it easier for other people to utilize. Mm-hmm. And then once that's done, then we'll go through and do production analysis, where you look at okay, we're going to build 10 of these a year, we're going to build 20 of these, whatever that number is, and you look at what those materials cost is, what the labor to do it is, to put it together, and what the cost to maintain it is. Because not only when you take and put a cost on a device, not only do you have, okay, I have this hat, it's got 75 cents worth of materials and $1 or something in labor, but I have to ship it somewhere, and I have to tell someone how to use it. And so creating this manuals and providing this phone support, the email support, all cost money. And if you don't plan for that up front, you'll never stay in business.
Yeah, sure. Are you committed to this? Are you in contract? Do you contemplate being in contract?
Right now we have a memo of understanding, and we're fairly committed to this. It's like, unless something really goes wrong, I can't see any reason why we wouldn't stay involved with this, because this is just really one of many opportunities we want to take and pursue with the University of Hawaii.
Mm-hmm. What will happen to the intellectual property, under your arrangement? I guess the university will continue to own it, or will you be buying it or using it?
That is all to be defined so far. Most likely the University of Hawaii will take and maintain the rights to it, mm-hmm. but that aspect of it, right now we're in the process of doing a market analysis which identifies what the real need for the device is. So is this something we're going to sell 2 a year, 10 a year, 100 a year, 1,000 a year? And once you get that, then you can take and start talking about, okay, what's the proper business analysis? Is this a profit sharing? Is this a licensing? Is it, what is that relationship?
So clearly, there's something about this device appeals to you.
Yeah.
And so do you get to this point and willing to go down the track on it. What is it about this device that makes it worthwhile coming out from Columbus, Ohio, and taking all these steps? What do you like about it?
The first thing, it's in Hawaii, so it's like the weather's starting to get a little bit cold back in Columbus, and not necessarily nice. But beyond that, it fills a niche. There's a lot of unmanned vehicles that are larger, faster. Some of them are weaponized. Some of them are very high-speed platforms. And there's some very, very small platforms that are very limited in what they can do. And this is kind of a mid-sized platform that's designed to be low cost, and so it fills a niche that's not being filled right now. And so we see that as being a good thing. That and the fact that it's pretty much so sensor agnostic, it hasn't been designed to do one specific mission, makes it more interesting to a larger audience. Well, now what happens is we'll take and continue to work with the University of Hawaii, and I've taken some notes over the last couple days where I've been working with them to do the assembly and operation, point out things that, okay, works great for you, you understand it, you're putting this together in a non-stressful situation. In other applications, this won't work so well. And so those changes will get wrapped into the new design. And then what will happen is, right now we're planning on coming up this next year in May, having that system ready to do a deployment where we can take and work with someone who has a situation where either a storm's come through, there's a drowning victim, there's some application where we can go actually show the capability of it. And then after that, that will take and give us a little bit more appreciation of how well the clients are like how the system operates. Then we'll work on doing the transition technology. So we'll look at what needs to happen on our side of the house to actually transition that technology.
We also got a chance to talk with Margot Edwards, the director of the Center for Island Maritime and Extreme Environment Security, CIMES, which is the Homeland Security Center of Excellence at UH.
The Department of Homeland Security funded this effort, and one of the things that we struggle with, I think, as academics is developing a technology and then really rolling it out into the marketplace so that it's something that's useful. And this technology has been developed over a 3-year period. It's built entirely in Hawaii. It's been developed using a lot of Hawaiian students, graduates from Mililani High School over here, and so it's in Hawaii, it's for Hawaii, and now we're hoping that we can roll it out to the rest of the world. I'm the director of the Center of Excellence, right? We have a bunch of principal investigators who are doing different kinds of technologies. Brian is one of them. We have engineers, we have scientists, anybody who's studying on or below the ocean surface. There are other projects that are as interesting. Certainly our spaceflight laboratory is a bunch of people coming together with sensors and capabilities to develop, satellites going off. I think that's a really exciting one too. But to your point, one of the things that I said that I think is really important is for our young people, our brightest and best minds that are thinking about going to the mainland to go to college, if you want to study maritime robotics, you've got the place right here where you want to be studying it. The University of Hawaii is cutting edge in terms of developing these technologies.
So what about the intellectual property? Is there intellectual property on this?
There is, and it's mostly in Brian's command and control software. He's spent a lot of time, and I don't know if you've had the opportunity to see it, but how this little boat can follow a straight line in the water when the wind is blowing and there's a little bit of chop on top of the water, that's a tricky problem, and they've developed an approach that allows them to do that very accurately. They can steer at a particular point, but they can also follow a specific line, and that's really something that's got a lot of people interested. So what's important here is the platform, and now other people are developing sensors, right? And we can just say, well, wouldn't it be interesting if we could use this sensor? In fact, the truth of the infrared camera is about a month and a half ago, Coast Guard came to us and said, it would be really useful to us if we could see a thermal signature of somebody who is trying to hide behind something. And okay, we'll put an infrared sensor on it. And a month and a half later, there it is. There's the capability. You're seeing it today. About 3.5, 4 years ago, the commanding officer then at the time of Coast Guard, Admiral Brown, Manson Brown,
yes,
came to us and said, we took all these Hawaiian Coast Guard folks to Louisiana after Katrina, and there's no blue clear water that you can see through. So we were nervous about bringing our boats into a place where we knew that cars and houses and debris had been pulled into shallow water. Can you help us with that? And that's the conversation that started this whole development that you're seeing today. If there's a molasses spill, right, and you can't see what's going on through the molasses, you could use the acoustic system to be able to literally use sound to see what's going on the bottom underneath the molasses. Similarly with the infrared, right, you're looking for temperature versus stuff that you can see in the visible light bands. So yeah, you'd be able to do a lot of that sort of stuff. Right now it doesn't have the lift capability to be able to pick stuff up. But one of the things that I think the Army would be interested in doing in shallow water, so if we were over on the Ordnance Reef side and you picked up ammunition, so you're trying to do remediation, are there chemicals that are released into the water? And this system could be very useful for monitoring what happens in the water in real time. Fukushima, a big wave comes in, right? And it picks up cars, it picks up debris, it brings it out into the harbor where there might be radioactivity too. You don't want to put people in the water, right? You don't want to endanger the people. You take a robot like this out, you go out there, you survey what the chemicals are, where the debris is. You make sure that it's safe for the people before they actually start the response, so you don't have these cascading problems of the helpers themselves becoming in need of help. One of the great potentials for this is just surveying what's happening in a region over and over again. Once a month, I'm going to go to this harbor, for a commercial company, or maybe I'm going to go to Hanauma Bay and make sure that it's not getting a whole bunch of algae growing in there, and I'm going to survey it every month. It's not expensive and it's not hard. You don't have to use divers anymore. That's the message, is you can use this robot in place of putting people in the water and potentially endangering them.
This is a perfect example of how CIMES is working in Hawaii and for Hawaii. The collaboration between academic researchers and private companies like Battelle in transitioning new knowledge and technical innovations is critical for homeland security right here in our islands.
UH Vice President for Research, Vasilis Sirmo, said the University of Hawaii is proud to be working with Battelle on new Hawaii-developed technologies.
Pat Gruber of Battelle said, "We're pleased to continue this relationship with the University of Hawaii and believe we can make great advances in maritime security by combining our strengths."
The Coast Guard and the State Harbors Division have provided advice in the development of the vehicle. UH has also been working with James Long of Custom Fabrications in Kaneohe to fabricate it.
And good for UH for having created a device that will make Hawaii famous in harbor and port security. Its commercialization is exactly what we need to show our stuff in world-class tech and gain a world-class reputation for tech.
Congratulations to everyone involved. We hope there are other inventions like this in the UH pipeline and that we'll see another one soon. Score one for UH and for Hawaii. You can also score one for Homeland Security.
And now, let's take a look at our ThinkTech calendar of events going forward.
ThinkTech streams video and audio of all of its shows live on the internet from 1 to 5 p.m. every weekday afternoon, and we replay them all night long on ustream.tv. Visit thinktechhawaii.com for our live stream and YouTube links. Raise your awareness on ThinkTech.
And now, here's Bill Spencer, President of the Hawaii Venture Capital Association, with this week's Spensation.
So, Bill, I got a flyer the other day about the VC Summit. What's going on with the VC Summit?
Well, this is sort of the venture capital event of the year, in my opinion, Jay. The VC Summit is going to be an all-day event at the Sheraton Waikiki on December 4th. And the first half of the day is going to be events and activities and workshops interesting to the entrepreneur. For example, there's going to be a workshop on crowdfunding. We spoke of that in a previous Spensation. And then there's going to be some case studies for venture finance, which will be very informative. And then there's a luncheon with a keynote from a fellow named Don Dodge. And Don Dodge is a Google Ventures advisor of preeminence. He's a great speaker, and I think it'll be real exciting to have somebody who's at the heart of the excitement in tech, at least as far as Google is concerned, to talk to the crowd. And then in the afternoon, we're going to have Startup Paradise Demo Day. And this is the capstone for the accelerators that are operating now in Hawaii. Blue Startups, which has 7 entrepreneurial teams that will present their business plans to the group. And then the Energy Accelerator, which, as you know, just got $30 million from the Department of Defense, non-dilutive financing for energy ventures. So all those entrepreneurial teams will present their business plan, and it should be very exciting to see what they've been doing. So I think it's going to be a good event. Like I say, it's sort of a capstone for the year. And then we'll follow that in January with our Hawaii Venture Capital Association ThinkTech Deal of the Year and Entrepreneur of the Year award ceremony.
Okay, Bill, looking forward.
Sounds good.
Thanks.
All right.
See you there.
We'll be right back to wrap up this week's edition of ThinkTech. But first, we want to thank our underwriters.
Hawaiian Electric Company and its affiliates, Maui Electric and Hawaii Electric Light Company on Hawaii Island, are deeply committed to the communities they serve.
Galen Ho is a senior executive of BAE Systems, a global defense, security, and aerospace company.
The High-Tech Development Corporation, the state's leading technology agency attached to the Department of Business, Economic Development, and Tourism.
Castle & Cook Hawaii, with a time-honored legacy that spans more than 160 years and revolves around its mission of investing in Hawaii, creating communities, and providing for the needs of our state.
Hawaii Gas, formerly the Gas Company, a proponent of the Liquefied Natural Gas Initiative, helping Hawaii achieve its transition to clean energy and a better energy future.
Collateral Analytics, a Hawaii-based tech company empowering the real estate industry with greater and faster access to the tools and data they need to make better informed property investment decisions.
The Foreign Trade Zone, operated by the Department of Business, Economic Development, and Tourism, encourages international trading in Hawaii and brings the benefits of the Foreign Trade Zone program to Hawaii businesses and entrepreneurs.
Okay, Maria. That wraps up this week's edition of ThinkTech. Remember, you can watch ThinkTech on OC16 several times every week. Can't get enough of it, just like JFI Dell does. For additional times, check out OC16.tv.
Totally, Duke. For lots more ThinkTech videos and for underwriting and sponsorship opportunities on ThinkTech on OC16, visit thinktechhawaii.com. Be an underwriter, a sponsor, or a volunteer, and help us reach Hawaii.
I'm Duke Oishi. Thanks so much for joining us on ThinkTech. You can watch this show throughout the week and tune in next Sunday evening for our next important weekly episode. Aloha, everyone.
I'm Maria Kashem. See you next time.